Okay, so we're going to use mathematical induction to prove that this statement is true. So first thing we're going to do is we are going to test. So we're going to test for when n is equal to 1. So when we're testing, all that means we're going to do is substitute into our expression. Okay, and 2, so this top part will simplify down to being 2. So 2 to the power of 2 is 4. This will stay as -3. So -3, -1 makes -4, which equals 0. So we could also say that as 3 times 0 is equal to 0. So therefore, true. Now, if you're not happy about this statement, you could test the next one up in the statement, but it should be true for everything that is a positive integer. That's what this means. Remember, the Z symbol stands for all elements of the integers, and then this is the positive integers only. Okay, so next thing we're going to do is we're going to assume. So when we're assuming, now that I should have said it up here, this one is the initial statement. Proving that it's true initially is your initial statement. Now we're going to assume. We're going to assume that n is equal to k. So 2 to the power of k minus 3k minus 1 is equal to, we're saying it's divisible by 3, so this statement needs to be equal to 3 lots of some number, where a can be any element of the real positive integers. Okay, so that statement here, you really do need to make that. That's important. This part on the end here is also probably worth a mark. Okay, so the next thing we're going to do is we're going to prove. And we're going to prove when n is equal to k plus 1. Now, this is our inductive step here. So this is going to be the one that helps us make this statement all come together. Now, I'm scrolling down because this is going to take a bit of space for us. So first thing I'm going to do is substitute into the expression. Anywhere where there was an n, I'm going to put a bracket and k plus 1 in the bracket. Okay, and that will change into 2 to the power of 2k plus 2 minus 3k minus 3 minus 1. Now, I'm just going to clean this up a little bit, and I'm going to adjust the way that this is written. Now, when we're doing proof by induction, our goal is to use this statement here, and we're going to prove the next part of it, the k plus 1 statement, as our inductive step. So I'm trying to get the 2 to the power of 2k minus 3k minus 1 so I can replace it with 3a, because that's going to help me prove that this thing is divisible by 3. So first thing I want to do is I want to separate these two out. So when I think about this as an expression, okay, I'm reminded of my index laws. So that's 2m plus n. Now, if I've got something like that, that means that before that, I had 2n times 2n, just like this, which means that this is another way of saying 2 to the power of 2k times 2 to the power of 2. So these two statements are equivalent. So first thing I'm going to do is I'm going to replace that 2 to the power of 2k times 2 to the power of 2. Remember, the point of doing this is I want to get this part here will match that. So now I can do the minus 3k minus 4. Now, here you can see that it's not quite the same statement yet. If I convert this into being a number, 4 times 2 to the power of 2k minus 3k minus 4, you can see that I can get two parts of that statement. I can get this part here has been increased by a factor of 4, and this part here has been increased by a factor of 4. So we're going to examine that part first to show you what's going to happen. So when I factorize the 4 out, I'm left with this. Okay, and that gives me this part and this part from my initial statement. Now, I am missing this part here. The problem that I've currently got is this doesn't have the factor of 4 in front of it. But I can use some tricky algebra steps to make it equivalent so I can put the 4 in front of it and separate the terms out. Okay, because remember, if I start with like 4 bananas, I can really say that I had 6 and I lost 2. That is the same as saying 4. It's just a different way of saying it. So here's what we're going to do. 4, 2 to the power of 2k minus 1. And now this part here, I'm going to now, minus 3k will stay there. I'm going to add and subtract the terms that I want. So the part that I want to go in here is minus 3k, and I want it to have the 4 in front of it, like that. Sorry, a minus 4 in front of it. Screw it, it doesn't matter either way. So, and then if I've added that on, I can take it away. Okay, I haven't changed the expression, I've just adjusted the way that it looks. Now, the term that I want to go in here, I want it to have a minus 3k. And this has got the positive 4 in front of it. So the one that's going to get condensed in is this, because it's got the positive 4 and the minus 3k. So this is going to be equal to now 4 to 2k minus 3k minus 1. Okay, so I've factorized the 4 out of this one and put it at the front with the other one, so I've just included it in the brackets. Now I can look at simplifying what I have here. So if I look at the negative 3k, that part's fine. Negative 4 times negative 3 makes positive 12. So 12 minus 3 will make 9, plus 9k. Now I'm not done yet. I've currently got this statement here. Now this matches that, which means that it can be replaced with 3a. Now, I can already tell that this is going to work out and it is going to be divisible by 3 because this has got a factor of 3 in it. That's obviously got a factor of 3 in it. But just for clarity, I'm just going to do the next couple of steps to show you exactly how this should look. So I've now expanded the brackets. I've factorized a 3 out of the front to very clearly show that it does have 3 as a factor. Even if I could factorize out a higher number, I wouldn't. I would leave it as 3. So now I've got the 3 in front of it, just like when we did our first part, we had the 3 times 0, which proves that this does have a factor of 3. So my final thing to do is to make a little statement here. So, therefore, this is proven true. We'll write the whole thing. Therefore, 2 to the power of 2n minus 3n minus 1. Remember, this means is divisible by 3. Is proven by mathematical induction as n equals 1 is true, n equals k is assumed true, and n equals k plus 1 is proven to be true also. You could also add in by mathematical induction on the end there. Now, if you look at the syllabus, at the mark scheme from QCAA, they may have made it a smaller statement at the end here. I'm not 100% sure how they're going to judge this when they mark it. I think the best and the safest way of doing this is to write the full statement, making sure that you hit all of those pieces of information.